Alright guys, I'm going to show you now how to use the calculator to do a two-sample test using the same things I did before. Running this test made me realize that I had mistyped when I entered the mean here. I should have written 45.8 and I wrote 45.6, which made my SD off slightly. So I did this over just in case you're curious, and it's basically the same, right? This used to be, I think, negative 0.256. Now it's negative 0.276. It's still very, very close to zero, but if you were bothered by this, then hopefully you watch both videos and discover that, yes, it should have been that. Interesting. I don't know how to make that blight go away. Okay, so anyway, what I'm going to do then is I'm going to do each of these over on the calculator and show you how to do it, because it's a pretty different action between the two. But remember that nasty, horrible formula we had for degrees of freedom? Where'd it go? This nasty thing? Remember, we decided to go more conservative and do it this way, but it's unpooled is what this means, so that it's the standard deviation of each sample is considered. So we do want unpooled data, and the calculator is not going to agree to do this anyway besides this horrible way, but the calculator is doing it for you, so yay. But then if you go use that information on something that you're submitting where you're supposed to be using this, then it won't work, okay? So the calculator is doing it the better way, but it's not the way you're expected to do it if you're doing on-ramps. Okay, so here's what I'm going to do this in the right order. I'm going to use add lists and spreadsheets. And I'm going to, if you have it in a spreadsheet, you actually can copy and paste it, which is kind of nice. So I'm going to do that. Oops. It has to still be blue. If you click on it twice and get that cursor, you can't paste anything except a single cell. So here are our values. So then I'm going to go Menu, Statistics, Tests, two-sample, t-test. We're getting it from the data because we've given it the lists. If we just were given the means and the standard deviations, we'd use stats. So let's first do it like this. So I'm going to say that my first list is A, my second list is B. I don't want to pool it. I am using this standard not equal to business. Each list only gets one frequency. And here it is, okay? So see, this degrees of freedom is nuts. So the way we do it would only ever have whole numbers, but this one's got this crazy mess. 12.73 is going to give Z values or T values for the regions that are a little bit closer. So when we played that more conservative version, we're making it have to be farther away to be significant. The p-value we have not really used, but you'd be comparing the p-value if you wanted to the 0.025 or 0.05. We'd be comparing that to the 0.05. This is clearly much, much, much larger than 0.05 when 1 is as big as you can get. So we still definitely fail to reject the null hypothesis. Here's where I saw that this was off. So 45.8 it should have been. The standard deviation was changed slightly also. So there are the standard deviations, there are the ends. So this gives you all this information that I've put down there, except for t-critical. So if you're using t-critical, you'd still have to use that normally. Okay? Because remember, we didn't give it alpha. So if I wanted to two sample t-tests. Let's say I want to give you the stats because somebody's asking me a question and what they've given me is stats, not values. The first mean was 43.1, first standard deviation 23.1, and N for that was 8. The second mean was 45.8. Second standard deviation was 18.4, and N was 12. So now the rest of it's the same. So you see that these are the same values. Degrees of freedom. Degrees of freedom. This slight variation is due to the fact that I rounded on both the means and the standard deviations. The p-value is almost identical because it's based on that, right? So everything is almost the same, and the only difference is that I rounded stuff. 43.125, I rounded to 43.1, okay? So that's where the changes come from. And then it's otherwise the same. Okay, so this is how we deal with it if it is independent, an independent t-test. There's no way to indicate it on the two tests. Let me just show you and then not insert one yet. When I go to this test, oops, nah. There may be something I don't understand about the calculator, but as far as I can tell, this is the only two sample t-test, and it never asks you if it's independent or dependent. So what we would want to do is we're going to take these initial values, put them in there. So now we have all our pairs. And what I want is to just look at the difference and run a single t-test on the difference. You see this equal sign right here. I can go here and say I want this to be A minus B. And it'll fill out the rest of this column where it's done, so it gives me this column here. Okay? Now, I would just stat test, t-test, data, and I want it to look at C, because that's where all the differences are. Mu should be 0, and I want to get it from C. Okay. Okay, so here's my test. Here's my p-value, t, which is different from my t for reasons I don't understand. Degrees of freedom, 9. Standard deviation, 12.36. They got 10.29. Well, you're welcome to look at my calculations and see what I did wrong there to get the wrong standard deviation. Weirdness. So the standard deviation is the difference. The 10 is the same. This scrolls very fast. Okay. Not sure where that test has gone. Anyway, so because it was mu does not equal mu 0, that's when we had to tell it mu 0 is 0. And the p-value, of course, is closer. It's 0.076, but that's still greater than 0.05. So we still reject the null, fail to reject the null. The mnemonic, remember, is if p is low, the null must go. I want to see. Okay, so I have yeah, I definitely don't understand where they're getting this 10.28, but it used to be that we didn't divide by one fewer for samples, so that's why I tried it dividing by 10. Anyway, when I write a lab and you have the RStudio versus calculator versions, I'll always make it accept both. So I'll do it in the calculator itself, and whatever it says is what I'll put in there. Still don't know why it's doing that, though. It's really odd. Okay, so this is how you do each type on a calculator. The one is just like a normal t-test, but you just tell it A minus B in column C and then look at column C only. And the other way, you give it both lists and you say to sample, and then it'll of course give a different thing than if you did it by hand, because the degrees of freedom are calculated like appropriately. And that's that.